So we have seen how once the classification tree is built, how we can use it to actually make decisions. Okay, the tree itself was of course constructed by the computer, and then once we have the tree, we can just use it to make decisions going forward. Earlier human beings were making those decisions, now the computer can just make the decisions based on this model. Okay, so now what we are going to do is to start looking at the process by which the computer looked at the data and figured out that this is the best tree. So we're going to start looking at that process. It involves lots of simple steps which come together in a nice way to actually build the tree. So what I'm going to do now is to walk you through several individual concepts and then put them all together. Okay, so of course what will happen is that initially I'll be asking you to take a few things for granted. Just take them for granted and only focus on what I want you to understand at that point in time. Gradually everything will become clear. So let's move on. So that was the tree that we had, and we are now figuring out how did the computer arrive at this tree. Okay, so now of course we know that this tree was built based on the training data that we had, historical data. Okay, so of course, as you know from what we've already looked at, we had some amount of data, historical data that was available to us, and we said we are going to partition that data into two parts, the training part and the test part, and we are going to use the training data to build the tree. In other words, we are going to hand over this training data, the training partition, to the computer and tell the computer, hey, figure out the best tree for this. Meaning do your machine learning magic and tell me what the tree is. Okay, so let's assume that there were 1200 cases in the training partition. Okay, so what the computer did was it looked at all the 1200 cases in the training partition and said, after all, it's a tree, so it's going to figure out a bunch of decisions. So it first said, let me take these 1200 cases and break them into two parts. One part consisting of all the cases for which the income is less than or equal to 100,000, and another part for which the income is greater than 100,000. Okay, now remember, we are looking at not how to make a decision using a tree, but how the computer actually constructed the tree from our training partition. Okay, so a classification tree, as you know, is just a bunch of decisions. So the computer has to figure out what are the decisions at the various points. Okay, so here it figured out, again, we will learn the process by which it figured out that this is the criterion on, to apply to the training data initially. Why income? Why not age? Why not education? Why not credit limit? Why not credit lines? We'll come to all of that later. Okay, so applying a certain process, which we will unpack later, the computer said, I'm going to take the 1200 cases in the training partition, break it into two parts based on this particular condition. Okay, so now let's see that, of course, each of the 1200 cases is going to run through this decision and either get thrown into this bucket or this bucket. Okay, so this bucket will consist of all the cases for which income is less than or equal to 100,000, and this will consist of all the cases for which the income is greater than 100,000. Okay, let's assume that 800 cases fell into this bucket and 400 cases fell into that bucket. Okay, so now we have taken the original 1200 cases, broken it up into two buckets of 800 and 400. Okay, so now the computer is again going to look at taking one of these buckets and then splitting it into two parts once again based on some criteria. Okay, so let's assume that the computer chose this bucket to split into two parts. Why this bucket? We'll see later. And why split it on education less than equal to 1? We'll see that later. Okay, so it's considered all possibilities and said this is the best one to split on at this point. Now, what do we mean by best? Why this? We'll come to all of that shortly. But for now, just focus on understanding that the computer figured out that this is the best thing to do. How it figured out, we'll see later. Okay, so now it said, I'm going to take all the 500, 800 cases in this bucket and split it into two parts based on this criterion. So once again, let's assume that 300 people had education less than equal to 1, 500 had education greater than 1. Okay, so now we've got three buckets: 300, 500, 400. Of course, the total has to be 1200 because that's how many we put into the top. And initially we split it into two buckets, and we took one of those buckets and split it into two buckets. So now we have three buckets. Once again, the computer has to figure out one of these buckets and split it into two parts. Okay, and so you can see how by this process a tree is getting constructed. Okay, this is clearly part of the larger tree that I showed you earlier. So this is the process by which the machine learning process builds the tree. Of course, there are still unanswered questions about this, which we will gradually address. Okay, so now let's proceed further. Of course, this process of choosing a bucket and splitting it into two parts can go on forever. Okay, not forever literally, because our data set is 1200, and once you reach a bucket that's got only one case, you can't split it anymore. So that's the ultimate case of when to stop. Okay, but you can even stop before that, right? Because after all, what we are really saying is, let's say you did a split and then you arrived at a bucket, and within that bucket all the cases were of a single type. Right? In other words, suppose here I reached this bucket. This bucket has 300 cases. Okay. Now let's say that all the 300 cases in this bucket were ones for which we accept the historical data gave them the loan. They were all accepts. In terms of target attribute, they all had the same target attribute value. Okay, so what you're effectively saying is, in the historical data, if the income was less than 100,000 and education was less than equal to 1, then for every one of those cases in the historical data, we said the decision makers gave them the loan. Okay, so obviously that would make sense to follow that practice in the future as well. So in the future, if somebody comes along and they fall in this bucket, right? In other words, they have income less than equal to 100,000 and education less than equal to 1, then obviously it would make sense for us to give them the loan. Okay, because historically 100% of people who satisfied that condition were given the loan. And after all, what we are trying to do is to take the patterns in the historical data, apply them to the future, right? So if in this, suppose we have reached a case where the bucket is pure, that is, the decision is completely unanimous, then there is no need to split that any further, because anybody who comes into that bucket gets the loan, because historically they always got it. Okay, so when all the nodes become completely pure, right? When all the buckets that you have on your hand with potential to split, all of them are pure in terms of all the cases being either accept or reject, then you can stop building. You can stop splitting further, right? But of course, this is not going to happen. Here's an example of that. Okay, let's say some tree at some point you reached this level where there were 50 cases here, all of them were accept. 40 all accept, 75 all reject. Okay, so notice that each one of these nodes is pure. Okay, it's got cases with only one target attribute value. The other target attribute value doesn't appear. So here all are accepts, here all are rejects, here all are accepts, here all are rejects, here and here all are accepts. So all the leaf nodes are pure, so there's no need to split anymore. Okay, that's one case, but that in practical data that almost never happens. Okay, And even if it did happen, you would probably end up creating very, very big trees, big in the sense of deep trees, leading to many, 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 many decisions before you can reach that point. Okay? And there are lots of disadvantages with having trees which are very big. We will look at that also later on. Okay? Uh, and the other point is that you may end up with leaf nodes that have very few cases, right? Here, notice that you're saying, I've got 50 cases, all of them were rejected in the historical data. Okay? So you feel pretty confident that that set of criteria definitely needs to be rejected because historically it was unanimous. And that decision was based on 50 cases. That's quite a large number. So you are not taking any risk by applying that criterion going forward. On the other hand, suppose your leaf node here, instead of 50, this was 3. Okay? That means, yes, the node is pure, but it has only 3 cases. So just because historically there were 3 cases and all of them were accepted, it doesn't mean that it's a very sensible thing to apply going forward because 3 is such a small number on which to make your decision, on which to base your decision. If it was 20, yeah, that's a large number. Even 15, you may say, yeah, that's a large number. If it's unanimous, yeah, that's good. Okay? So if you go on splitting the tree more and more and more and more, the size of the nodes will keep getting smaller and smaller and they become not very suitable for basing your decision on. Okay? So that's out. Waiting for pure nodes is out. That's not going to work. So the practical consideration that we take or that machine learning takes is to say, let's create trees which are neither too big, too deep, nor too shallow, nor too small. Okay? And you can control that by using one of 2 criteria. You can say, hey, I'll keep on splitting the nodes, but I need a node to be at least of a certain size before I even split it. I meaning the computer. You tell the computer, don't split a node unless it has at least X number of cases. Okay, so we can set this at any value and then say, in order for considering a node to be split, it has to be at least of this size. Okay, so obviously that will restrict the size of the tree, right? Because at some point you'll say, stop, it's not going to split any further. That's one criterion. And the other criterion, potential criterion, is to say min bucket. In other words, I want to make sure that my process of splitting doesn't create any nodes which are too small. Okay, so I can say create a tree, but don't create any buckets which are less than 30 or 20 or 50, whatever we want. Okay, so let's see how min split works. Min split says that in order for a node to be considered for splitting, it has to have at least a certain number of cases. Let's say min split is 30. Okay, so of course we know that in this particular tree, the total number of cases coming in is 150. Okay, so our initial bucket is 150, which is greater than min split, so we can split it. Okay, so let's say we go ahead and split it into 2 parts, 50 and 100. Okay, so this node has 50, this node has 100. Now both of them are still bigger than min split, so each of them can still be split. Let's say we take this and split it into 2 parts, we get 40 and 10. You know, the 50 was split and it became 40 and 10. Now this 40 can still be split because it's greater than min split. But this 10 node cannot be split because it's now become less than the size which we require for it to be split. Okay, so this can be split because it's got more than 30. This cannot be split anymore, it stops. This can of course be split because it's got more than min split. Okay, so this is one criterion by which we can control the size of the tree. The other criterion is min bucket, which says don't produce a node which has less than min bucket cases. Let's say we set our min bucket at 20. Okay, so once again, the initial 150 cases are coming in. If the potential split is, the computer figured out that the potential split is attribute 1 less than 50. If you do that split, you end up with 50 and 100. Now 50 and 100 are both bigger than min bucket. So this split doesn't create a bucket which is less than 20, because the buckets it creates are 50 and 100. So go ahead, split. Okay. So let's consider this node now. So this one has 50 cases, and the potential split is attribute 2 less than equal to 30. But if you did that split, you will create nodes of 40 and 10. 40 is fine, but 10 is not fine. Because now this bucket, if you did the split, you're creating a bucket of size 10, which is less than min bucket. So this split is not allowed. Okay. So that's how these two criteria work to control the size of the tree that we build. Okay. So now we'll go ahead, and look at the summary of what we just looked at, which is when do you stop splitting? When your nodes are pure, right? Or we use our two criteria of min bucket and min split.